Today's lesson is our fourth multiplying fractions lesson. There are two I can statements. I can statement number 1 is a repeat of last week. I can use an area model to multiply fractions. And the I can statement number 2 is one that we will complete by the end of our in-time class. I can develop an algorithm or a rule for multiplying fractions because we notice patterns in the area model. So for us to notice patterns, we need to do a few more examples of the area model. But before we get there, a quick warm-up. What fraction of this square is gray? All right, if I number the parts, there's 1, 2, 3, 4. It looks like the fraction is 1/4. But there's a big misconception in the answer 1/4. It's that this third part here, and the fourth part, but this third part is way bigger, way larger, has a bigger, larger area than the first part. Denominators in fractions must have equal parts. And in this picture, we don't have equal parts. Right? So I'm going to erase this, and instead I'm going to grab my pencil tool and I'm going to extend this line here all the way across, maybe move it up just a little bit so it matches. And now I can see that I have parts that are the same size. I have 1, 2, 3, 4, 5, 6 equal parts. So the denominator is really 6. So this fraction was 1/6. Let's do that again. What about this one? What fraction of this square is gray? You don't have access to my drawing tools in Notability, but you do have access to screenshotting. So that's what I'm going to do. All right, if I press into that screenshot, now you can see I have all the tools on the side. So I'm going to zoom in. Right? And I can see there are 1, 2, 3, 4, there it is, 5, 6 parts colored in, but I need to have equal sized parts. These parts above are way larger than the parts that I numbered. So again, I'm going to extend those lines, do the best I can to make them straight. Doesn't have to be perfect. Oh, let's grab the pencil tool instead. Extend those lines, doesn't have to be perfect. Best of my ability, right? And now I can see that I have 7, 8, 9, 10, 11, 12, 13, 14, oh, this is taking a while, 15, 16, 17, 18, 19, and 20 parts. So this fraction has to be 6/20. The other way that I can see that it's 20 without counting every single one of them, I could count by 4s, 4, 8, 12, 16, 20. I could do that, or I could count the columns and say I have 5, 10, 15, 20. Or I could say, well, this is an array. It's repeats. I have 5 repeats of 4. Here it is. There's 4 in this stack. So instead of skip cutting by 4, I could say that I have 4 5 times. There it is. And that'll also get me to the 20. Here's the first time. Harder to write with this tool. Second time. Third time. I'm effectively counting the rows. Fourth time. And the 5th time. I have 5 rows of 4. 4 times 5 is 20. All right. Done. Delete that, and we'll head back to it. So this fraction was 6/20 because there are 20 equal parts. I won't cut them up again, but there are 20 equal-sized parts. One of the I can statements of this lesson was to develop a rule or an algorithm for multiplying fractions. But before we can have a rule, we have to find a pattern. So we're going to do a few more examples like what we were introduced to earlier this week. This is a picture of the cake that Kathy has remaining after a party. This is what's left over. What fraction of the cake does she have left? If I number the slices or the parts, I can number them already because they're all equal sized. And if I number them, I can see there are 4 gray parts out of 7 total parts. So 4/7 of the cake remains. Now, 3 of those 7s are eaten. That's why they're white. So we're talking about the gray parts there. Now we can be sure that this is a picture of the remaining cake. 4/7 of the whole cake remains. Kathy comes into the kitchen and decides to eat 2/5 of the remaining cake. How could she find 2/5? Well, probably the most important part here is that we're talking about the remaining cake. The picture that we have here doesn't show just the remaining cake. It shows the whole cake. That's the outside. I'm going to cover up the part of the picture that shows the cake that's been eaten. There we go. So now all we're looking at is the remaining cake. She wants to eat 2/5 of that. So if she's going to eat 2/5, then I need to take this picture and cut it into fifths. So I'm going to do that to the very best of my ability. I'm going to make rows across because I already have my up and down or vertical lines. Grab a skinnier pencil here. Here's 1 line. Here's 2 lines, 3 lines, and 4 lines. I know if I want to make fifths, I have to make 4 lines across. So here are my fifths. I'm talking about the whole way across. 1, 2, 3, 4, 5. I have 4 lines or 4 rows. So that's fifths. I'm also going to number them. 1, 2, 3, 4, and 5. Kathy wants to eat 2/5. So I'm going to highlight that 2 now. And this is where I see kids make a silly mistake. They say 2/5 is this. 1, 2. Now that's certainly 2 X's. But the problem with that is that there should be 5 total parts that are that size. But if I keep on counting those little pieces, there's 3, 4, 5, 6, 7, 8, 9, 10. That's way more than the 5 she needed for fifths. I think I'm going to get to 20 here. So if she's going to eat 2/5, she's not eating 2 slices. She's eating 2 rows. Here's the first row. Don't judge Kathy. She's hungry. Here's the very first row. 1 row. 2 rows. She's eaten 2 out of 5 rows, or 2/5 of the remaining cake. But what if I asked, how much of the whole cake is that? How much of the whole? If I change it now to be the whole cake, then I need to see the whole cake, and the whole cake needs to be in equal sized parts. So even though these pieces are missing, I'm going to pretend that they're there so I can see equal sized parts. They've already been eaten, all right? But in order to say what fraction this is, I need to know how many total parts there are. So this is 7 across, and it's 5 up and down. 5 times 7 is 35. There are 35 total parts. She's eaten 8, so she's eaten 8/35 of the whole cake. All right. So again, what fraction is that we're seeing? We're seeing 8/35. I can make those lines across. There are 35 little parts. She has eaten 1, 2, 3, 4, 5, 6, 7, 8 of them. All right. And now let's take a look at what the multiplication sentence says. It says she ate 2/5 of 4/7. Remembering that 4/7 specifically was the leftover or the remaining cake. She ate 2/5 of the leftovers. That's the same as 8/35 of the whole. But if I take this sentence of and change now, so now I want you to focus on the word of. If I change this of to a times, I can say 2/5 times 4/7 equals 8/35. And there's something special happening when you just look at the numbers. That's what we're going to explore in our synchronous, in our Google Meet time. During Google Meet time, you'll do problems that look like this. Right? So this problem says 3/4 times 1/6, but I want us to think about it slightly differently. We're going to call this 3/4 of 1/6. So we need to make sure that all we're thinking about is a sixth. In this picture, I'm pretty sure this is a sixth. I'm going to just double check though. There's 1, 2, 3, 4, 5, 6. There are 6 parts. If I want to find 3/4 of a sixth, then the very first thing I have to do is ignore everything that's not that gray part. So when you come into class, I'm going to ask you to also ignore it, to cover it all up. Hopefully you can do it a little faster than what I'm doing right now. Because all I want is 3/4 of this gray piece. So I'm going to cut that into 4 parts. That means in half. And then each half in half. And we want 3 of those. So I'm going to put an X, an X, an X. That's 3 out of the 4 parts. I'll also color those. You'll have access to the highlighter tool, so you'll be able to do that in Class Kick. So if I want to know what 3/4 of a sixth is, it looks like this. But the answer to the multiplication problem is saying, in terms of a whole. So how much of the whole thing have we now colored in? To figure that out, we extend our lines. And we can say it's 1, 2, 3, 4, 5, 6. It's 6 across. And it is, let's see, 4 up and down. So there are 3 shaded in out of 24 total parts. But I also want you to see that the quick way to get 24 is to do 6 times 4. Here's the 6 times 4. And the way to get that answer of 3 is, yes, to count them, but the other way to get that answer of 3 is to look at the rectangle that we colored in. Trying to make it nice and dark for you. It's 1 wide and it's 3 tall. So 3 times 1 equals 3. At the end, the fraction of the square that's shaded dark is 3/24 of the whole.